So welcome back. We're going to be starting chapter 4 today. And chapter 4 is going to be very similar to chapter 3. But where chapter 3 we were focused on like taking equations and graphing them. Now we're going to be creating the equations that we graph. So it's going to be very similar. A lot of times we're going to be working backwards, taking a graph and making an equation out of it. So if you felt comfortable more towards the end of chapter 3, like you were getting the idea of graphing, this should be very familiar. In fact, a lot of the students seem to really like it today. So we're going to start off in 4.1, which is writing equations in slope-intercept form. Also a very popular form of an equation because they've covered it several times over several previous courses. We've even covered it this year in this course a few times. So again, they've got a few years worth of experience with this, so they like it. The y equals mx plus b, we need two things. I need a slope for the m and I need a y-intercept for the b. The slope typically is going to be the rise over run. We did cover a formula, I'll show it here in a minute, where we pick and choose different parts of the formula for slope depending on what we're looking at. And so let's go ahead and get started. In the beginning, when we write an equation, all we're really needing is we need a slope and a y-intercept. So these three are best case scenario. We like these. These really help us out because when I'm plugging them into this equation, y equals mx plus b, I've got my m and I've got my b. Most of the first three are just making sure they can differentiate which one's m, which one's b. I don't know which is which. Well, in this case, again, the slope is going to be an m, and the y-intercept is going to be the b. So I'm going to say m is -3, so -3x. And the y-intercept, they get the 1/2, but a lot of them forget, okay, is the 1/2 a negative or a positive? In this case, the 1/2 is a positive, so I'm going to make that plus 1/2. And that's it. Easy enough. Now the next two questions, numbers 2 and 3, are going to be what happens when I have a 0 mixed in there, because students freak out when there's a 0. Don't worry about it. Fill it out to the best of your ability and see what you can do. Now, which form of the equation are you using? Y equals mx plus b. We're always going to write this down because the next two sections I'm going to introduce two other versions of an equation of a line. And we want to make sure we're using not the right one, but we're showing which one we're using. So that way I know as your teacher, oh, you're using this form. I need to see that you've identified a slope and a y-intercept at some point. Okay, so let's go ahead. Y equals something x plus b. In this case, our slope is 3/4, so I'm going to get a 3/4 x. And my b is, well, 0 is neither positive nor negative, so it doesn't really matter which one you put. I'm going to put plus 0. Now, the big thing with a plus 0 is we know that it cancels out. So my real answer is just going to be y equals 3/4 x. Bingo. Same thing with this one. If I see a 0, a lot of students freak out. There's no reason that we need to freak out. I'm going to use y equals mx plus b to solve this one. So I need to plug in an m and a b. In this case, my m is going to be the 0, and my b is going to be a -2. So notice how when it's a positive, I put plus. I could have put either. This one I'm going to put minus, because that plus b just means, sorry, there were some really weird noises coming from outside, because this is being filmed immediately after school, so kids are still on campus, and they make weird noises sometimes. Yeah, okay, cool. We're going to ignore that. Moving on. So the 0x in this case, remember 0 times anything is 0. We're going to say this cancels out. Why? Well, 0 times x is 0. 0 minus 2 is -2. So in essence, I can kind of ignore that 0x because it's going to work itself out of the equation. That's why we say it cancels out. Awesome. So we see even when we have a 0 thrown in there, nothing crazy happens. Now, on the next set of questions, we're doing the same thing as we did right here, but I'm giving you the information in a slightly different way. I'm giving you a graph as opposed to in a nice, neat little function right here. Now, this is when I pause and I give them and I say, where am I going to put this? Because I put it on the other board earlier. We're going to say that slope, let me do this in blue. And this is something we've done in a previous lesson. We know that slope was written as the letter m. Slope is the rise over the run of a line. What does that mean? We said, well, the rise is how far it goes up. So it's the change in y. The run is how far it moves, so it's the change in x. Now the change in y we write as a delta. So change is delta. big change, big delta. So big delta y, big delta x for the change in x. There we go. And if I wanted to do it with coordinates, I would say y2 minus y1 over x2 minus x1, because it's the difference or the change between any 2 points. Now, the big point that we mentioned was that this was really good for graphs, this was really good for tables, and this was really good for coordinates. You don't need to write out the whole thing each time, but you're writing out a different version of it, just like there's different versions of lines. What's the most useful version? Do I need to pay in dollars? Do I need to pay in pesos? Do I need to pay in kroner? What exactly am I paying in? What's most useful at the time? In this case, we're going to say this is very useful for graphs, so I'm going to use rise over run. But before we get there, I need the same 2 pieces of information I've been needing. I need the y-intercept, and I need the slope. Okay. The y-intercept, they've got it down. 1, 2, 3, it's a -3. No issue with that. They all get this. The slope, they've got it, but they don't really know how to show that they've got it. So with this, again, I'm going to use the graphing version of the equation and say I need a rise over run. So here's how I show it. I say the slope is the rise over the run. Okay. Well, what is the rise? Well, I'm going to look from one point to the next, meaning from the left to the right. How far up or down did I go? In this case, I went up by 4. Okay, so I went up 4. My run, I went to the right. Did I say up 4? Really? That's up 6. Ignore me. I can't count. Up 6. Jokingly, that's the point of this, to see if they can count. I went to the right by 4. Okay, so if I went up 6 and right 4, let's take a notice. How do I write up 6 in math? Well, we say up 6 is plus 6. How do I write right 4? I would say that is plus 4. Okay. Then when we get to this point, I ask, okay, does 6 divide by 4? No, it doesn't divide by 4. They pretty much all get this, but does it reduce? We're starting to get to the point where they can reduce fractions. So I'm super excited. We've been working towards this for a while. So it feels really good that they're starting to get the hang of it. So 6 divided by 4, those both divide by the number 2 because they're both even. So this will end up being a 3/2. Boom, there's my slope, is a reduced form of that. Now that I've got my slope and my y-intercept, it's just a rinse and repeat of what we did over here. What form of the line are you using? I'm using this form of the line. So that means I need an m and I need a b. So my m is going to be 3/2. My b is going to be a -3. Bingo, that's it. So you're starting to see that, hey, we need those 2 pieces of information for y equals mx plus b. I always need a y-intercept, I always need a slope. If I look at this one over here, again, I need the same 2 pieces of information. Nothing about this has changed, my y-intercept and my slope. So my y-intercept in this case is a 2. And my slope, I'm going to count how far up or down I went. Let's see if I can count correctly this time, because lots embarrassing if I can't. So from my left to my right, I went down by 3. And then I went to the right by 4. Okay. So let's go ahead and fill this out. Well, what form of the slope are you using? I'm using the rise over run technique, which tells me that I went down 3, and I went to the right by 4. Now, if up is positive, down is negative. So that's a -3. Right is going to be a +4. And then I asked, does -3 divide by 4? The answer is no. Does it reduce? Also no. So I get a -3/4. Now, does it matter where the negative is? Not really, as long as there is a negative in the answer and only one negative. It's either in the top or in the bottom or out front. Doesn't matter where, as long as there's only one. Because 2 negatives make a positive, so there can't be a second one. So I've got my slope and my y-intercept. So what I'm going to do is I'm going to, again, rinse and repeat the same thing that I did earlier. I'm going to write out what form of a line I'm using, y equals mx plus b. I need to figure out what the m is and what the b is. So here the m is a -3/4 and the b is going to be a +2. Bingo. So again, we see that we're going to take this information and rewrite it in a different form. Now, before we shift over to the board over here, I'm going to be using, instead of this portion of the slope, I'm going to be using this, and we'll see why here in a minute. Let's go ahead and switch boards. Boom. Here we go. So again, I'm taking the same set of skills and I want to apply it. Let's say I don't have a graph. Before we had 2 graphs. Now I've just got a table. So there's 2 ways we can solve this. One, I graph the table and I do exactly what I did before. Students are pretty good at graphing things. Now, again, the counting's the big issue. Sometimes they don't count the correct number of squares. Minor issue, easy fix. But this takes a little bit of time. I'd rather not. In fact, every time I asked them, they were like, no, we don't want to do that. That took too long. Who has time to graph? Because they don't like graphing. But I do have a better way to do this. So let's do it in a slightly faster way. Now, again, I need the same 2 pieces of information. I need the y-intercept and I need the slope. Okay. Well, I did ask them because it was one of the questions, it was one of the bonus questions on their vocabulary test that they took on Monday. I said, okay, to find the x-intercept, what do? Plug in a 0 for the other variable. So plug in a 0 for the y. If I want to find the y-intercept, plug in a 0 for the x. You always plug in a 0 for the other one. So if I want to find the y-intercept, plug in a 0 for the x. And do I have something with a 0 for the x? And the answer is yes. So I've got my y-intercept right here. Bingo. So my y-intercept, if I look at the table, is going to be -1. Now the slope, I'm again going to have to do a little bit of work to figure out this slope. But instead of doing rise over run, because that involves me having a graph, they didn't want a graph. Could you? Yes. But the point of this is to show you a different version of it. I'm going to use the delta y over delta x. Now remember, we said delta y is the change in y. The delta x is the change in x. So I need to make sure my change is consistent. So from one y to the next, what are we doing every single time? Well, 5 to -1, I went down. -1 to -7, I went down. -7 to -13, I went down. And when I say by how much, I went down by 6, I went down by 6, and I went down by 6. That is the same thing on every single part right there. So my delta y is -6. For delta x, I do the same thing. What am I doing to x every single time? I went right 3, right 3, right 3. Or I went up by 3, up by 3, up by 3 if I'm looking at just the numbers, which means that consistently the x is increased by 3 each time. Boom, there's my slope. I get a slope of -2. Now I did tell the students you could write this as a -2 over 1. If you want to write it with something that you're graphing, if I was about to graph this, which we're not about to graph, I would put -2 over 1 because that gives me my rise over my run. If not, I'm just writing an equation, so let's just stick with the -2. Now I've got my y-intercept and my slope. Again, this tells me everything I need. mx plus b. I need an m and I need a b. My m is going to be -2. My slope is going to be -1. That's it. So it's all about finding the y-intercept and finding the slope, no matter what form of information we're given. So again, if I'm looking at this table, I still need to find the y-intercept. I still need to find the slope. Okay? So for the y-intercept, I asked them, hey, do I see a 0 for the x? The answer is yes. Now at this point, somebody usually asks, what happens if we don't have a 0? Well, let's say I didn't have a 0 over here. This was not part of today's lesson. It will be part of a future lesson, but I had enough people ask me where I'm going to show this on the video just as a little aside. Okay. If I don't have a 0, let's assume this one again because I'll come back to this in just a moment. Let's say I didn't have that point, but I can still, let's say I don't have a 0, but I can find out the slope. So what I did was I would say, okay, if y equals mx plus b, if I only had these bottom two, I would figure out that the slope is going to be a -6. Okay. The next thing that I would do is I'd plug in any other point because I don't have this point. So I'm going to plug in the 3, -7. 3 is going to be for the y. Negative 7 is going to be for the x. Hold on. I said my slope was negative 2. I was like, that's not right. My slope is negative 2, so I plug in that. My x is negative 7. My y is 3. Completely wrong. Little dyslexic here. My x is 3 and my y is negative 7. My x is 3 and my y is negative 7. There we go. That's a little bit better. Long day. So I've got a negative 2 and a 3. So when I multiply the negative 2 times 3, I'll get a negative 6 equals my negative 7. I haven't touched the b over here, but I do want to get rid of the negative 6. How do I do that? I add 6 to both sides. That cancels that over here, and I'm left with a negative 1 equals b, and therefore that'll give me my b if I don't have it. Now, that's not what we're doing today, but that is to answer a lot of those students' questions who are starting to think ahead on these things. Also, if I confused you on that, I apologize. Normally when I switch something, I only do it once. I don't normally do it twice in a row like that. But, okay, let's go back to the question at hand. So my y-intercept right here is a negative 5.8. But my slope, again, when I start to do the work on the slope, I have delta y over delta x. My delta y, pause, we notice that nothing's being done. Again, we're getting good responses on this because I say, what do we say is nothing in math? And I'm getting a lot of people that are like, hey, 0. So the delta y is 0. Nothing's happening. Now the delta x is different. It's going up by 4, up by 4, up by 4. So my delta x is positive 4. And here's where quite literally I was like, okay, cool. I have a little fishing rod. When I have a 0 in the slope, what do I call that slope? Now if you said undefined, I just caught you. Because this is a big misconception that students are having. When they see a 0 in with the slope, they jump to undefined. It's undefined if the 0 is in the bottom of the fraction. Because what is 0 divided by 4? 0. Nothing special about that. It's just a 0. But if 0 was in the bottom and the 4 was on top, 0 does fit into 4 0 times. Not a big deal. It's a weird question to ask, but it fits 0 times. Does 4 fit into 0? And the answer is no. It's impossible to put something into nothing. So if the 0 is on the bottom, it's undefined. If the 0 is on top, it's just 0. I did ask a few of the classes, what type of line am I looking at? Some of them noticed that with the 0 slope, they said, hey, this is a horizontal line. That's awesome, because they're recognizing a 0 slope is a flat line. There is no rise, because the rise is 0. It's only run. Go up 0, go over 4. Don't go up any, go over 4. Don't go up any, go over 4. Don't go up any, go over 4. It's just a line that keeps going over. That's it. But let's jump back into what we're doing here. We want to write an equation, and we're like, okay, you gave us a lot of side information to figure out y equals mx plus b. Well, my slope is a 0, and my b is a negative 5.8. Oh, hold on. That cancels out. So my answer is just going to be y equals negative 5.8. Awesome. Now, the last type of problem is written in function notation. Now, this is the third time we've covered function notation this year. Not a lot of them remember how to do that. I did get a few in 6th period, which was really cool. They remembered how to. They got a little confused as to what was going in and what was going out. But when I read this function, this says f of 0 equals 10. This says f of 6 equals 36. So what does it mean? Well, what I told them is that, hey, remember, with a function, we have a machine. What is the name of this machine? F. The machine is called f. What does it do? I don't know. But what I do know is that when I stick something into the machine, it does stuff and spits out something. what did we plug in when I said f of 0 is 10? We plugged in a 0 and it spit out 10. I don't know what happened, but I got 10 back. So our goal is to write an equation to say what's going on inside that machine. Because right now we don't know. I plugged in nothing, I got 10 back. Well, maybe I plugged nothing into my bank account and there's $10 at the end of the day. Well, that means $10 is already there. But we did it again and we tried a second input. We said, let's plug in 6 and we got 36 back out. That's how we read that function notation. Okay, cool. Well, that's telling us that I have an input and an output. And what is an input in math? Pretty much every class. X. What's an output? Y. So what information is this telling us? This is telling us that I have an XY table that I didn't know about. This is saying that my input of 0 put an output of 10. My input of 6 gave me an output of 36. So I just rewrote that function notation into something that we just did 2 examples of. And now at this point, it's super easy. They say, okay, y-intercept is going to be 10, and then my slope, well, hold on, I gotta do some stuff for the slope. So I gotta say delta y over delta x. The delta y from 10 to 36. The change in y went up by how much? It went up by 26. From 0 to 6, what was the change in x? It went up by 6. Now, I didn't actually write it on this one. I got a lot of people that were confused after the fact. They said, well, where did the 26 come from? The 26, remember, is the change in y. It went up by 26. Well, where did the 6 come from? Well, that's the change in x. This went up by 6. So just keep that in mind, that's where that came from. I didn't write it in class because I assumed they got it at this point, but I had a few that were still stuck on that detail right there. Okay. Now 26 divided by 6, that doesn't divide, but it does reduce into a 13 over 3. So there's my slope, 13 over 3. So if I have an equation like y equals mx plus b, I have a slope of 13/3 and a b of 10. There we go. Now for the last one, I did give them a chance to solve it. Most classes did okay. I usually had about 5 or 6 kids in each class that managed to get this ahead of time. But I had a lot of them that were doing really good. So I'm going to ask you for an opportunity to go ahead and pause the video, try out the question, and then pause it when you're done and see how well we did together. That should be enough time for you to have paused it and tried it. So let's go ahead and do this. Again, I have a machine called F. And in this machine, I said, okay, I plugged in 0 and I got back a -4. I plugged in a 2 and I got back a 10. I'll show you where the common mistake was because some of you might have already spotted it. Okay. For my y-intercept, we got a -4. Easy enough. For the slope, what I had a lot of people write was they said the slope was 6. Or no. They said the slope was 6 over 2, which ended up being a 3. Can you spot the mistake they made? If I said the change in y was a 4 to a 10, that's good. But it's not a 4 to a 10, it's a -4 to a 10, which is going to change my delta y. So for my slope, I want to figure out what is the constant change in y over what is the constant change in x. For my change in y, I went up by 14, not up by 6. From a negative to a positive, I went up by 14. And then over here, I went up by 2, which is either a 7 or a 7 over 1. Now, are we graphing this? No. So I'm just going to use that form, 7. So for my equation, I want to be able to say y equals mx plus b. That's going to give me a y equals, my m is 7 and my b is -4. There we go. So like I said, super light and easy day. The students seem to really like it. They seem to really get it. I had a lot of good engagement throughout this lesson. I'm going to talk to you guys about the homework here in a moment. Let's pause and flip the camera. Okay, so here we go. So today is November 5th, and we just did a lesson over 4.1. We finished it, and they were assigned homework. Now, normally I have the homework due the next day. However, I've noticed that I've got the same kids doing the homework every day. A lot of the students just are not even trying. I've talked to a good bit of them as to why aren't they doing it, and they're like, well, there's not enough time to do it. Again, I try to assign less than 10 minutes worth of homework every day. So we're going to make a small change to when the homework is due. I'm going to assign it due this Friday. See if the extra 24 hours increases the homework completion rate. Now, big issue that we've had is I've had a lot of students copying out of the back of the book or copying each other's work or using AI assistive tools, which is why I tend to have a tight turnaround time with homework, is to prevent that from happening. I don't want to give them too much time to where they are too inclined to copy, but I also don't want to give them too little time to where if they really just need an extra 24 hours, let's give it to them. So let's try this out. I'm going to have for the next week or two, I'm going to have the homework due at the end of that week. So all the homework's going to be due on Friday. So tonight they have page 182, numbers 1 through 14. They're doing all of them, so it's 14 questions, but this should take them about 10 minutes. We're not looking at this taking 20, 30, 40, 2 hours. This should be very quick and very easy. What is the slope? What is the y-intercept? Go ahead and write that out. If they're having problems, remember tutoring times. Tutoring is before and after school. Make sure they come, make sure they get caught up. But most of them seem to be catching on, so we're really excited about this. And I'll see you guys tomorrow.